Hello everyone, and welcome back to now the fourth video, I believe, in our review on inference for proportions. This video today is going to cover specifically the two proportion z-test, and also, more specifically, how is it different from the one proportion z-test. So, let's jump right into those differences and get into it. So, the biggest difference with two proportions, when we look at our acronym, right, my hat, North Carolina. My hypotheses now are going to be about two proportions in relation to each other. So you're going to see something like P1 equals P2 for your null hypothesis. And then something like P1 is less than P2. What's important here is you want to use subscripts that make sense. If you end up using 1 and 2 as your subscripts, what ends up happening is then you have to define them right away. But if you have something, I remember there was a question about like a proportion in 2007 and a proportion in 2008. If you use P sub 2007 and P sub 2008, you don't need to define them separately because it's very clear from the problem. My assumptions now need to be true for both, but we also introduce something called the combined proportion, which is just your total successes over your total sample size. And the reason for this is that with a one proportion z-test, we knew we lived on the distribution of the null hypothesis. We knew what the number was, whether that was 0.2 or 0.5 or 0.7 or whatever it may be. When we talk about a two proportion, I'm just assuming they are the same, but I don't know what that number is. And so to get the best estimate of what that number would be, I pool the samples together, and this also gives a larger weight to the larger sample. Because the theory behind that is the larger sample will have a more accurate proportion than the smaller one. And so we use that combined proportion for both our sample size calculations, and we also use it in the test formula as well. It ends up being our denominator because that comes from the null hypothesis. And so this is now a two proportion z-test. My numbers stay the same, and my conclusion stays the same. Now, the nice part also is that your calculator will give you this formula, right? Or will give you this number, I should say. When you use a TI-84, it will just say P hat without a subscript. And that is your combined proportion. But if it's not a nice number that's recognizable to you right away, that's going to be hard for you to figure out because it is something you have to show to get full credit. So the best way to do this, I think, is to look at an example. So this is a study about does low-dose aspirin reduce the chance of developing colon cancer? And so here we had, it looks like 1,000 adults total. We had 500 in each group. We had 500 taking aspirin and 500 taking the placebo. So in this particular case, my null hypothesis is going to be that the aspirin group is equal to the placebo group. And here I'm using subscripts that make sense. The A for aspirin and the P for placebo. Now, in this case, we're looking at, based on this question, does taking a low-dose aspirin reduce your chance of developing colon cancer? So my alternative would be P sub A less than P sub P, right? I would have a lower proportion of people with colon cancer. When I look at my assumptions, right, so here's my hypotheses. When I look at my assumptions, I have random assignment, which is what I need. And then now, again, just like with a two proportion Z interval, I like to make myself a table. But the first thing I'm going to do is calculate my combined proportion. Now, in this case, it's very easy. It's your total colon cancer cases over your total sample size. So in this particular case, my combined proportion is 41 over 1,000. That's my total here. So if I'm going to make my table of my aspirin group, my placebo group, and then this is going to be essentially cancer and no cancer. Right, so this would be 500 times what's this, 0.041. And so this would be 500 times 0.959. And then same thing here. All of that is greater than or equal to 10. Right? 500 times 0.041 is 20.5. And so obviously that's more than 10. We're good to go. When I get to my test, this is now a two proportion Z test. And now my numbers, you would plug in on your calculator. I'm going to plug in on mine. And then we'll see what we get here. Now, again, in this one, they gave us a significance level. So that's going to be important. A significance level of 0.05. And so, in this particular case, what I get for a sample statistic, or for a test statistic, excuse me, is negative 1.227 with a p-value of 0.109 and my significance level of 0.05. So my conclusion stays the same here, right? As my p-value is greater than my significance level, we do not reject our null hypothesis, right? It is that straightforward and that simple. And actually, I take that back. I believe I did this wrong. I think that Z value is wrong. Please hold. Let me redo this. Yes, it is. I put in the wrong proportions. Please hold. I knew something was wrong here. So in this particular case, you get a Z value of negative 1.75, excuse me, 754, and a p-value of 0.04. So this changes our conclusion. As p is less than alpha, we do reject our null hypothesis. And so now there is evidence to suggest that taking aspirin leads to a lower rate of colon cancer. Boom, there we go. I knew something was wrong with that Z calculation. It did not seem right. And so notice here with a two proportion, it's the same basic structure, right? The only difference is now we're testing two proportions against each other instead of one proportion against a number. So again, I hope that was helpful, and I'll see you guys in the next one. Bye.